All right, everybody. I have been asked to work through the practice problems. Some of you said that me working through them helps you see what's going on. So I'm going to make a video. It's probably about an hour or so. This is not required for you to watch. It is only if you feel like it will help you. Okay. So with that said, I might run through some of these fairly quickly. Because remembering that you're only going to have about, well, if you're taking this as an online class, I have given you probably a 2-hour window, but I think you should be able to finish this test in an hour and 15 minutes like you would if you were in a face-to-face class. And in fact, I gave a version of this in my face-to-face class, and I think you can do it. So let's try to go through. I'm not going to give tons and tons of explanations, but I will point things out as we go. All right, number one, you're given this function 2x squared plus 7x and asked to, it says perform the indicated operations, but basically it's asking you to solve or find the derivative by using the definition. Okay, and I think we had a quiz on this where you had to submit your handwritten work where you work through all of this. So let's go through step by step. Step one is find f of x plus h. So we're going to plug in x plus h everywhere up there that we see an x. So here's an x and here's an x. And hopefully you've taken some time to work out these types of problems and you're like, yeah, I'm good with this. Okay. X plus h times x plus h. If you know it, you know it. And if you don't, you'll need to multiply it out, right? X plus h squared is the same as x plus h times x plus h. If you know what that looks like, it's x squared plus 2xh plus h squared. If you don't, then take your time and foil that guy out. Okay, plus I need to distribute this 7, so 7x plus 7h. So I also need to distribute this 2 through all of those terms. So I believe that f of x plus h equals 2x squared plus 2 times 2 is 4xh plus 2h squared plus a 7x plus a 7h. And yes, I want to see every one of these 4 steps. So don't skip it. Don't hop to the shortcuts. Now, if you want to come off here to the side and say, hey, I know the shortcut for this one. I know that f prime of x is going to be what? 4x plus 7. Absolutely. You can know that's where you're going, and we'll check that in a minute and make sure that my power rule shortcut answer matches up with my long. And if it's not, then I can go back and make changes. So we know that's what's happening here. So step 2 is f of x plus h minus f of x. Okay, here was my f of x plus h. I'm just recopying what's up there. Minus, and I'm going to put parentheses because, again, we tend to lose these negatives whenever we do this. The entire f of x, right? That entire function is going to go right here in the minus. Minus parentheses 2x squared plus 7x. That is the f of x, right? And the reason we put the negative and the parentheses is because we know we're going to have to distribute that negative sign through, right? So right now I'm going to go ahead and do that. 2x squared plus 4xh plus 2h squared plus 7x plus 7h minus 2x squared minus 7x. And again, we know if we did this right, the stuff that doesn't have h's in it, so the positive 2x squared and the negative 2x squared, those things that don't have h's in them, the positive 7x and the negative 7x, are going to go away. And we're going to be left with things that have h's. So this step is 4xh plus 2h squared plus a 7h. So there's step 2. All right, step 3. Take all that stuff you just did. We're going to copy it in a second and divide by h, right? That's literally step 3. It's in the definition. The definition is going to be somewhere on your formula sheet. You don't have to memorize it. I'm not trying to trick you. Okay. It's going to be there. All right. So all divided by h. So I see, hey, there's an h in each of those terms. So 4x, oops, I'm sorry, pull the h out. I'm left with 4x plus 2 h's plus a 7 all over the h. The h's will indeed divide out. And so I think this step, where I divided by h, is equal to 4x plus 2h plus 7. Okay. And the last step here, again from the derivative, is take the limit as h goes to 0 of all that stuff. Okay. So the limit is h goes to 0 of 4x plus 2h plus 7. Okay, now if you did your homework and you followed all this through, you know that this means plug in a 0 for h, right? It's the basics of what that means. It's a little more complicated than that, but that's what we've narrowed it down. So what I know here is that my f prime of x, the whole thing, is the 4x plus the 7. Okay, that's by the definition, or also known as the 4-step process, right? 4 steps. 1, 2, 3, 4. Okay, 4x plus 7. When we started, we cheated a little bit and gave ourselves a little hint where we were headed. We said, hey, this derivative is going to be 4x plus 7. We did an entire page's worth of work, and sure enough, at the bottom, 4x plus 7. If I didn't have 4x plus 7, then either I made a mistake on my shortcut or I made a mistake in all this stuff. The problem is probably in all of this stuff. And a lot of times the problem is with a negative sign, right? So watch out. Make sure you distributed your negative signs properly. There was even a problem where I messed that up, I think, on one of the videos. So work it out. Make sure it's correct, and then move on. All right, number 2 says, you are given a particular function, f of x equals 5x squared minus 12x minus 8, and it says find the following. And the first one says, it says the derivative. I'm going to write f prime of x. Okay. And before we go on, I want you to take just a second and ask yourself, what kind of derivative am I taking here? Remember, you've got a few options. Oh, excuse me. Is it a power rule? In that case, it means like it looks like all the exponents are real numbers. Out here, we've got also real numbers out there, right? So I think it's a power rule. Okay. My other options are product rule. Nope, there's nothing being multiplied here, like 2 functions times each other. Quotient rule, remember that's like a function divided by a function, so that's not it. This isn't division. Or chain rule, and that's some chain rule means there's a function inside of another function, right? It's a composite function. None of those is true, so this looks to me like it's just a power rule. And on all of these, I highly recommend, before you take the derivative, because I'm not telling you what rule to use, you need to look at it and say, which of those 4 rules am I using? This is a power rule. I'm going to multiply exponent times what's out in front, subtract 1. The exponent here is a 1. Subtract a 1, that's going to become a 0. X to the 0 is a 1, so that's just a 12. And we know that any constant number, the derivative of that is just 0, right? So here we go. Found the derivative. Good deal. Okay. And then it says, what does the derivative represent? Oh, I'm so sorry. In this case, physically on a graph, what are you finding? Okay, so this is like a short answer question, right? I want you to use your words. So remember, physically on the graph, what are we finding here? The graph is a quadratic, and we are finding the what? That's the slope of the what? Tangent line, right? Okay, so slope of a tangent line. And at this point, it's at any point at this point in time, it's at any point, right? I picked that guy right there, but you could also have had it over there. So this is the generic slope of a tangent line. Once they tell me what x is, I can tell you a specific slope of a line. So for instance, this point here has a positive slope. This point here has a negative slope. Clearly, they're not going to be the same, right? So the slope of the tangent line depends on which point you give me. So right now it's just slope of the tangent line. Later, if I give you an x value, it's at slope of a tangent line at whatever the x equals was. Okay. Oh, what is the slope of the tangent line? I'm sorry, there was a part C to that problem, and I marked it out. See, what is the slope of the tangent line to the curve of f of x at x equals 3? There we go. So now I'm giving you a specific point. It's actually not hard to do. I just take this and plug it into the derivative, right? So f prime of 3, 10 times 3 minus 12. That's a 30 minus 12. Well, that's 18. So it wants to know what is the slope of the tangent line. By the way, that's kind of the answer for part B, right? Slope of the tangent line to the curve of f of x at x equals 3 is 18. That's all you do. Just plugged it in. All right. Now I can go to the next problem. Number 3. Find the derivative of the following. Use any method. Show work as much as possible. And I'm going to tell you for this test, you need to show work. Okay. Maybe here on A, there's no work to show. You could show a little bit of work, but I'm okay if on A, you just find the derivative. What kind of, this is a weirdo because he's just a constant, but technically, what kind of rule am I using? Power rule, right? Okay. So what's the derivative of a constant? F prime of x is 0. So that one, okay, you don't have to show the work. It really is some work going on here though, right? This is x to the 0. Remember when we multiply out in front, 0 times 175, and then subtract 1. We don't care what happens to the exponent because 0 times any number is a 0. So you really could use the power rule there. We just know that there's that shortcut rule that says, oh, if it's a constant, we don't have to use the power rule. We can just say, hey, derivative of any constant is a 0. Okay, g of t is 5t to the 6th. Again, I think it's a power rule, right? Okay, so I'm going to use power rule and go ahead and do this on your own. This one should be pretty fairly safe and fast. 30t to the minus 1 is a 5, right? Okay, so I don't think you're going to have several of these that are kind of, I expect you to be able to do them pretty quickly, right? C says g of u equals u to the 5/4. You better be able to do this real quickly. Press pause if you need to. I think this is a power rule, so all 3 of these are power rule. Okay. G prime of u equals 5/4 u to the subtract 1 from this guy. 5/4 minus 4/4 is 1/4. Notice that it stays positive there because 5/4 is a fraction bigger than 1. So when I subtract 1, I still have a leftover that's positive. Okay, all of those were power rules. Okay. Number 4. Find the derivative of each of the following. Use any method. Show work as much as possible. Now, I want you to look at this guy and tell me What's wrong with it to begin with? It's not wrong with it, but we don't like it the way it's written. What's wrong? It's written as a fifth root, Dr. Webster. Hopefully you see that, and this quickly you can rearrange it. 7 times x to the, what's the power? 1 over, what's the root? 5. Flower power, right? The power goes on top, the root goes on bottom. That's the way a flower works. Power is in the top, in the petals and all that. The roots are on the bottom. Okay, so have I taken the derivative? No, I did not. I am rewriting this. Okay, that's all I'm doing is rearranging it. I think I actually have one on the test. I can't remember exactly. I wrote it a few days ago. But I think it says rearrange this. Okay. Show me that you know your exponent rules. That is part of what I want you to show me here. Okay. So now I have h of x equals 7x to the 1/5. What kind of a rule is this? I think it's a power rule. If you can't look at it that quickly and say, "Oh, this is being raised to a power," then go back and, I don't know, work on some of the homework or something, because we've done a ton of these. Okay. Multiply your power out in front. 7 times 1/5 x to the, subtract a 1. 1/5 minus 5/5 is a negative 4/5. Okay. And that can be cleaned up a little bit. So I think h prime of x equals, this is 7 over 1, 7/5 x to the negative 4/5. I am okay with leaving it that way. Or 7/5 times 1 over x to the positive 4/5. Absolutely. You can move that to the bottom, the x to the power to the bottom, and make it a positive exponent. Or if you want to go ahead and rearrange it again and put it back into a radical. I'm not going to do that one. I don't feel it's necessary. I'm fine if you stopped here. Okay, so don't feel like you have to do all this extra stuff. You didn't have to. That was part B. I'm sorry. All right. Oh, no, I'm sorry. That was only A. Oh, it's because I rewrote it. So rewrite it first and then take the derivative. Sorry about that. Okay. 4A. 4B. F of x equals 7 over 2 square roots of x. Again, notice that this looks yucky. I don't like it. I'm going to rewrite it or rearrange. Absolutely. I don't like this the way it looks. So I'm going to find f of x equals, okay, the 7 halves, it's fine. But I've got 2 things I need to deal with here. On the bottom, so I'm going to write the 7 halves out in front. I've got 1 over. First thing is I'm going to rewrite this as x to the 1/2. Okay. And then the second thing is I don't like that in the bottom because I can't use the power rule the way it is. So I'm going to move x to the 1/2 to the top. In this case, I'm okay because the 1 is up there and it's not a big deal. It's just x to the negative 1/2, right? Okay. So that's not bad. I just needed to rewrite it. I still haven't taken the derivative yet. Okay. But the way I rewrote this so that it's a power, right? So I'm going to use the power rule. Okay. So far, all I've used after we did that problem that was the derivative by definition is power rule stuff. So the power rule covers a lot of stuff. Remember that. It's the most often used shortcut that we have. Okay. So power rule, multiply this guy out in front. Negative 1/2 times the 7 halves times the x to the, subtract 1 from the exponent. Be careful. Negative 1/2 minus 1 is negative 1/2 minus 2 over 2, negative 3/2. Okay. And now I have 2 different things going on. I'm going to simplify these fractions first. straight across these are multiplied, so straight multiply straight across the top. 1 times 7 is 7. Multiply straight across the top and bottom. -2 times 2 is -4. Okay. And then I also have x to the -3/2. And again, you can leave it like that if you want to. This one I'd probably move to the bottom, and I don't know why. I just feel like it looks good on the bottom. Probably it started down there at the bottom, so I'm like, yeah, I'll move it back down. But either one of those, and again, if you want to change that x to the 3/2 into a radical, feel free. It would be x to the 3rd inside of a square root. Okay. All right. 4b, 4c says f of t, 3t to the 7th minus 6t to the 5/3 plus, that should be a t. Sorry about that. 8t minus 12. There's not going to be anything crazy where I mix variables. Okay. That's not what we're doing here. Okay. Maybe on the optimization problem, but these guys are not. So that's what I'm looking at. They are all t's. I'm sorry. Okay. I don't have to do any kind of rearranging. This is a power rule. Hopefully everybody sees it as a power rule. I'm going to go ahead and take the derivative. Multiply the 7 out in front. That's 21t to the subtract 1. That's a 6. Multiply this 5/3 out in front. I've got minus 6 times 5/3 times t to the, I'm going to subtract 1. 5/3 minus 3/3 is 2/3. Okay. And then remember that this is t to the first here. So multiply that in front. That's not so bad. Plus 8 times 1 is 8. And then be careful here because when I subtract 1, 1 minus 1 is a 0. And then we have that exponent rule. Anything to the 0 power is a 1. 8 times 1 is just 8. So I am good to go. And then last but not least, right here, derivative of a constant is 0. There we go. Okay. I could probably clean this up a tiny bit. So the derivative, 21t to the 6th, minus 6 over 1 times 5 over 3. 6 times 5 is 30. Over 1 times 3 is 3. That's a 10. 21t to the 6th minus 10t to the 2/3 plus 8. Because that'll reduce, right? Okay, so that's all fine and dandy. That's actually probably the nicest one out of number 4. They're all power rule again. Okay. Go back and look at it if you're not sure why it's a power rule. Go back and watch one of those videos if you need to. 5a says, find the derivative of the function, show all work in order to receive full credit, simplify as much as possible. So 5a says f of x equals 1 minus 2x to the 3rd times 5x squared plus 7. And I look at that and go, whoop, that's not a power rule. Okay. Now, technically speaking, could you distribute this through and make it into a power rule? Yeah, you could. But at some point, that rearranging stuff gets old and you make mistakes. So I'm just going to look at this guy and go, hey, this guy right here is being multiplied by that guy right there. This is a standalone polynomial. This can be a standalone polynomial. I think this is the product rule. And if you look in your D2L, I have these problems already worked out. And you can see where I've written, I wrote right up there, what do I think this is? This is a power rule. Okay. First times second. That's what it looks like. So the derivative of that is, if you don't remember, go look at your formula sheet when you get there. But the derivative of that is the first guy times the derivative. That's the first guy, right? times the derivative of the second guy. Use my fingering covering technique if you need to. Well, the derivative of this is 2 times 5 is 10. X to the minus 1 is first power. That's a 7. That's a constant. I don't care about you. So first times the derivative of the second plus, there's a plus in that formula. The second, write him down just the way he is, times the derivative of the first. Well, the derivative of the first, be careful. This one is a 0, right? Because it's a constant. But be careful because you've got a negative sitting out in there in front. So when I multiply this guy, the 3 times what's out there, it's technically times a -1 out there, right? So -3 times 2. Okay. X to the, what's going on here? 3 minus 1 is 2. Okay, excuse me. And we know that -3 times 2 is a -6. No worries. All right, I see right here that I've got on this front guy here, the 1 minus 2x to the third. This is being distributed through. I'm going to multiply it through. And in the back, I've got this guy being distributed through, multiplied through. So I need to finish that out. F prime of x equals 10x times 1 is 10x. 10x times -2 is -20. X times x to the third is x to the fourth. Be careful with your exponent rules. Okay. This is a -6. I already said that. So -6 times 5 is a -6 times a positive is a -30. X squared times x squared is x to the fourth. And then -6 x squared times 7 is -42 x squared. Okay. And a lot of times when we work these problems, we know we'll end up with some like terms in there that we can come back and combine. So I'm going to rearrange these so the x to the fourth are at the beginning. So -20 x to the fourth, -30 is -50 x to the fourth minus 42 x squared plus 10x. There we go. That's how that product rule looks, right? Okay. Keep going. And again here, if you really wanted to, you could have foiled this guy out, distributed it, and turned it into what looks like a power rule. And you would end up with something that looks like you used a power rule. So if you must, fine, but it just takes a lot longer, I think. So be careful doing that. It can really swamp you. 5b, f of x equals, I've got x plus 4 on the top and 1 minus 6x on the bottom. And I see here, oh, look, I'm dividing. This guy on the top would be a polynomial. This guy on the bottom would be a polynomial. I can use the quotient rule. Yay. All right. So where this is my top and this is my bottom, so f prime of x equals, this will also be on your formula sheet, but you got to know how to read the formula sheet to be able to use it, right? So the derivative is the bottom, low d high. This is my saying. You say it how you want to. Minus high d low, low low. Okay, use the formula sheet, do it however you see. But it's the bottom, 1 minus 6x, times the derivative of the top. Well, the derivative of the top is just what? A 1, right? Because 1, 1, x to the 0 is a 1. This becomes a 0. So times 1 minus, because there's a minus in the formula, the top guy, high, x plus 4, times the derivative of the bottom guy. Okay, again, the constant goes away. 1 times -6 is -6, and that becomes x to the 0 or a 1. High derivative of low minus low times, I'm sorry, low times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay. You're going to get major points if you get that far, but you're not going to get all the points if you leave it like that, right? Okay, you need to simplify this a little bit. Clean it up. Make it prettier. Okay. F prime of x equals, well, this part right here is nice because when I distribute the 1, it doesn't change anything. That's good. 1 minus 6x. Okay. But this part's going to be a little bit messier. Okay, for two reasons. One is that I'm distributing that negative 6 through, right? It's not showing very nicely. It's got to be a clear right there. And the other is that I need to distribute this negative sign out in front through. Okay, so be careful with that. We do it properly. So I've got, if you wanted to, you could combine this with this because they're both being distributed and say it's a positive. That would be fine. Okay, but either way, negative 6 times a negative becomes a positive 6 times the x is a positive 6x. And then negative 6 times the 4, I'm sorry, times the negative becomes a positive 6 times the 4 becomes a positive 24 over, and just leave that stuff on the bottom alone. 1 minus 6x squared. Okay. And then one more step here. 1 minus 6x plus 6x plus 24. Hey, look at that. The 6x's on the top will indeed go away. A negative 6x and a positive 6x. So I've got 1 plus 24, and I think that that is 25 on top. Over that stuff on the bottom. 1 minus 6x squared. All right. Cool beans. I know I'm working through this quickly, so if you need help with quotient rule, go push pause, redo that, go back, look at it again, go back to the section in the content that has that video, watch it again if you need to. You can do it. You just have to be able to hopefully look at things pretty quickly. Look at the function that you're given, rearrange it if necessary, decide what rule you're going to use, and go for it. Right? Okay. 6 says find the derivative of the function, same as before. Show all the work in order to receive the full credit. Simplify as much as possible. A says f of x equals 4x squared plus 3 all raised to the 6th power. Okay. It doesn't matter if this is the 6th power or if it's the 522nd power. Okay. This is going to work the same. When I look at this thing, I see, oh, look, there's a function on the inside and there's a function on the outside. The outside function says take whatever's on the inside and raise it to the 6th power. And again, it doesn't matter if it's 600 or 6 or 600 here. Okay. So I've got something raised to the 6th power. That's the outside function. The inside function is what's in the parentheses there. Okay. Sometimes the inside function might be inside of a radical. But whatever's on the inside, it's its very own function. Okay. So I look at this and see this is a composite function, a function inside of a function. Okay. And I know I need to use the chain rule. Okay. And hopefully you know that as well, right? Okay. So how do I do that? Remember, I'm going to take the derivative of the outside function. So f prime of x equals 6 comes out in front. The stuff in the middle just stays along for the ride for now. Okay, we're just dealing with the outside. So just rewrite 4x squared plus 3. It's the same. Just carry it right down here. I'm not doing anything to that. I'm just dealing with the outside function. So the derivative of the outside function, that was a power rule, right? Okay. And what I do is I say 6 times whatever's on the inside raised to the 6 minus 1 is 5th power, right? That's the derivative of the outside. Then I'm going to look at the inside. Hey, look, that's a power rule too, right? So really, I'm just taking 2 power rules here. I just have to know that I need to do it, right? So inside, so the chain rule says, and again, it's on your formula sheet, take the derivative of the outside. I did that. Leave the inside alone. And then afterwards, multiply times the derivative of the inside. 2 times 4 is 8. X to the minus 1 is the first power. Okay. Derivative of the outside times the derivative of the inside. Okay. Again, the part people don't love is that stuff right there on the inside. It's just along for the ride. Don't play with it. Don't do anything. Just leave it there. Okay. I see I've got an 8x and a 6, and I can multiply that to make it 48x. And then here, all the stuff on the inside just stays there, raised to the 5th power. Okay. And again, if that had been 600 up there for the power, now I've got 599. I don't know about you, but I'm not going to waste my time raising or multiplying 4x squared plus 3 times itself 599 times. And I'm also not going to waste my time multiplying it by itself 5 times. So leave that alone. This part right here, 8x and the 6, clean that up. I feel like you can do that. I did it very quickly and I saw that it needed to be done. Okay. But you do not need to do anything with this stuff right here. Leave that junk alone. All right. So chain rule, that's the 4th one. We have power rule, we have product rule, we have quotient rule, we have chain rule. Okay. So 6b says find the derivative of the function. Show all work in order to receive full credit. Okay. F of x equals 1 over 5x squared minus 4 to the 3rd power. Okay. Now, I see this as 2 parts, okay? There's a quotient thing going on here, and down here on the bottom, I've got a chain rule thing going on here, okay? I don't want to have to deal with those both at the same time. Oh, if I don't have to, so I'm not going to. I'm sorry, it's a really long week for me, and it's only Sunday. Okay, so I see I can rearrange this automatically. So I'm going to make this 5x squared minus 4 raised to the negative 3. Okay, I'm not taking the derivative. I'm just rearranging it. Or sometimes I call that a rewrite. Okay. Okay, I rearranged it. It's still going to be a little bit complicated here because now it's still a chain rule, right? But I don't have to deal with the fact that it was a quotient thing before, and all by just moving it to the top and making that derivative, or I'm sorry, that exponent negative. So that wasn't too much to ask to keep me from having to deal with the quotient rule here. So chain rule, let's do it. We just did one a second ago. Okay. F prime of x equals, take the derivative of the outside, negative 3 times, leave the stuff alone, 5x squared minus 4 raised to the minus 1 on the outside, negative 3 minus 1 is negative 4, right? So this is just taking the derivative of the outside. The stuff on the inside looks exactly like it did before. That's how I take the outside derivative times the derivative of the inside. Now ignore the exponent out there. That is what? The derivative of that guy is 10x, right? Pull this guy down. This is a power rule, right? Actually, they were both power rules again. You just have to know how to take it, right? So the derivative of that guy is 10x. The derivative of the 4 is a 0. That goes away. I don't worry about him. Okay. Again, I can clean this up just a tiny bit. Negative 30x times the stuff on the inside to the negative 4th power. Now, again, if you don't love having the negative 4th power, you can rearrange that, move that to the bottom. I'm fine with it, but I will leave it just like that. I know sometimes in your My Math lab it's a little bit picky, but I don't care. Okay, number 7. According to a study conducted in 2023, The number of US jobs that are projected to leave the country by year T, where T equals 0 corresponds with 2020. Think we're gonna need that information, so I'm just writing it off to the side. T equals 0 is 2020. Um, that particular function is given by n of t, capital N of t, equals 0.0018425, big long nasty decimal, times t plus 5 raised to the 2.5. Okay. And then it says 0 is less than or equal to t is less than or equal to 15. Okay. Let's talk about that. What they're saying is this model is going to work okay for me from time equals 0, so 2020, up to year 15, which is 15 years later, so 2035, right? So we think this model is good in this time period. They're just letting us know. N of T is the number of jobs in millions. Ooh, millions. Okay. How fast will the number of US jobs that are outsourced be changing in 2025? What's the rate of change? That's what we want to know. Okay. How fast is it going to be changing in 2025? Well, let's think about it. If this is 2020 at 0, what year am I looking for? 2025 is year 5, right? T equals 5. Okay. So I know I'm looking for T equals 5, 2025. Okay. Does that make sense? That's this year, at least at the time that I'm making this video. Okay. So what's the rate of change? Oh, hang on a second. This is actually the number they're asking me for. What's the rate of change? Ooh. Rate of change, IROC IROC is the instant rate of change. That's the derivative, right? Oh, we know how to do that. M prime of t equals, take this whole thing, multiply it out in front, 2.5, 0.0018425. I'll come back for you in a minute. T plus 5 raised to the, take this exponent, subtract 1, I get 1.5. Okay. Am I finished? Be a little bit careful here. This is the derivative of the outside, but there's some stuff going on inside of the parentheses here. So when I look at that guy, technically it is some stuff, and I need to take the derivative of the inside. This is the derivative of the outside. I need to take the derivative of the inside. So I see this as a chain rule, is what I'm telling you. But we're going to luck out here because 1 times 1 is 1. And when I subtract 1 here, I get t to the 0 is 1. So this is all 1. And the derivative of the plus 5 is a 0. So all this is just times a 1. And I don't care about that, right? So I'm actually pretty fortunate there that I'm not going to have to mess with it too much. So I've got n prime of t is, let's clean that up, 2.5 times 0.0018425. There's that. So the decimal out in front actually is a lot nicer. It's 0.00461. All of that stuff, right? Times t plus 5 raised to the 1.5. Okay. So now I've got how fast the rate of change is, and I need to know at time t equals 5. So they're telling me when to plug in here. A lot of times we just leave these generic, but they're actually saying, hey, go in there, figure out t equals 5. So 5 plus 5 is 10 raised to the 1.5. Figure out then at that time how many jobs are being outsourced. So this is just a nice, pretty function. I can use my please excuse my dear Aunt Sally order of operations. 10 raised to the 1.5. Oops. 1.5 gives me that number, and then I'm going to multiply it times 0.00461. 461. And I get 0.14578. Okay. Number of jobs that are leaving, and it says in millions. Okay, so in millions, let's see what we got here. This number is in millions, so I can take it. Okay. 0.14578. 578. I can take that number and multiply it by a million, which should have 6 zeros, right? And what I'm getting is 145,000. The number that's changing in 5 years is 145,780 jobs. It's a lot of jobs that are leaving per year in 2025 is what it's saying. Okay. All right, there we go. It's a bunch of jobs leaving the U.S. Most people want the jobs to stay in America, right? That's what we would like to see happening, I think. Okay, number 8 says, explain conceptually what would have to be happening on the graph of f of x if the tangent line to the graph was horizontal. Okay. The easy way for me to do this is by showing 2 different parabolas. This is what I did probably in your notes whenever we covered this topic, and showing you that horizontal tangent line. Now, this can happen in all kinds of ways, right? And in fact, we see later when we do second derivative tests that sometimes weird stuff happens, point of inflection and stuff like that. But normally, whenever we have a horizontal line for the tangent line, what we have here is a maximum or a minimum, right? Okay. So max and min at tangent line that is horizontal. That's the concept that I hope that you got out of working with these derivatives. Okay. So explain conceptually. You may want to draw a picture to help yourself see or explain. There we go. In other words, if the tangent line is horizontal, what must be happening at the point on the graph of f of x? Hint, if the tangent line is horizontal, what would its slope be? Well, what is this slope? M equals 0, right? When those lines are horizontal. Okay. So draw a graph or something like that to support yourself if you need to. Absolutely, you can do that. All right, let's keep going. We're getting there. Number 9. I know it takes a while to work these out. A subsidiary of Electra Electronics manufactures a programmable MP3 player. I know these numbers are really big. I'm sorry. And seems like a lot of cost for just an MP3 player. Management determined that the daily cost of producing these MP3 players in dollars is given by C of X equals 0.0001 x to the third minus 0.08 x squared plus 40x plus 5,000. I apologize. I made up some of these problems and I made them so that they would work nicely. I didn't care if they made sense, okay, or if the numbers were nice here. I want this to work nicely. So it says, here's your cost function. Management determined that. They gave it to you. X stands for the number of MP3 players that are produced. Okay. Find the actual cost to produce the 301st MP3 player. Okay. Now, if you remember, the cost of the 301st is equal to, you make all 301 of them, and then you subtract out the cost of the first 300. Does that make sense? Remember that? That's the actual cost. Okay. So we did a problem like this in your notes. Go back and watch if you need to. So this is in the marginal cost section. So the actual cost, find the cost of making 301 of them, subtract the cost of 300 of them, and you'll have just left over the cost of the actual next unit, the 301st guy, right? Okay. So, and this the actual cost. So they're not asking me to do any crazy derivatives or anything like that. They want me to actually use the cost function right there. Okay. So cost of the 301 of them is, I'm going to plug it in. We'll see what happens math-wise. Right now, I'm just plugging in the 301. 40 times 301 plus 5,000. Okay, this is some big numbers. Remembering that we need to do the cubing or the squaring first because of my order of operations, and then we'll multiply. 0, 0, 1. Okay. So this first number is about 2,727.09. Okay. 301 squared. Again, I do the exponent first, then I'm going to multiply it by 0.08. And that's a minus, so minus 7248.08. Okay, and then finally 301 times 40, and that is a positive 12,040, no cents. And then I also have plus this 5,000 sitting back there, right? Okay, so let me get those numbers punched in together. 2727.09 minus 7248.08. You can punch this on your own calculator and make sure you're doing it right. Plus that, plus that. Okay, so the cost of making 301 of these guys is $12,519.01. That's not my answer. That's the cost if I made 301 of them, right? My problem said take that and we're going to subtract off the cost of making 300. So I need to do this again. Cost of 300 equals, plug it in, 0,001 times 300 cubed, 0.08, 300 squared, 40 times 300 plus 5,000. Okay. Start over. 300 to the third power is that big number times the 0.0001, 3 O's. Okay, that's 2,700 minus, because there's a minus sign here, 300 squared times 0.08. That's a 7,200. And then 300 times 40, that's 12,000. Plus the 5,000. Don't forget him. He's hanging out at the end. Okay. Now, some of you will want to punch this on your calculator, and I say go for it if you know how, but just be really, really careful with your order of operations. Make sure you use parentheses appropriately because sometimes things happen and we don't get it right. So be careful. All right. So I punched those all in, and I think that this is 12,500. Okay, to make 300 of them. Well, this kind of makes sense because now the difference between them, remember, the cost of the 301st item is the cost of the 301 of them, 12,519.01, minus the cost of the 300 of them, 12,500. And the difference there is $19.01, right? Yeah. It's negative because I did mine backwards, but that's okay. I know it's actually positive because I just entered them in the calculator backwards. If you want to enter it correctly the right way, go ahead. Okay, the actual cost of the 301st item. We got it. And there are times when I'm dealing with accounting and I got to put some numbers in the actual spreadsheets, the actual accounting databases or whatever you're using. There are times when I need that actual honest to goodness cost. Okay. However, it took me a little bit of time to get there, right? And it's kind of slow and it's a lot cumbersome and you have to be careful. Modern days, they'd probably just use a computer to help them figure that out and not mess with it. All right. Sorry, I needed a drink. My throat is getting tired. Okay, that was 9A. 9B says find the marginal cost. Now, this is where my derivative comes into play, right? So, what we need to do, if you'll remember, is find the marginal cost means take the derivative. So C prime of x equals, go back up to the original, 0.0003 x squared minus 0.08 times 2 is 0.16 x plus 40. Okay, take the derivative. I did that. And remember, the only thing you have to be really careful about here is when I want to find the 301st guy's price, the marginal cost is how much it costs to make just that one item, 301st guy. Okay. I don't put 301 in here, so be careful about that. That's the only thing you kind of got to be careful about. If I want it, I put in the previous item, right? I put in the 300. 003. Oops, I've got 0003 times 300 squared minus 0.16 times 300 plus a 40. Don't get weak on me. I don't know why sometimes that pen kind of runs out of go juice. Okay, plus the 40. There we go. All right, calculator time. 300 squared. That number right there, multiply it times 0.0003. I get 27. 300 times, I'm going to go ahead and say a negative 0.16, negative 48, plus 40. Okay, so negative 48 plus 40 plus 27. Okay, 19. Okay, the marginal cost, what this is telling me is the approximate cost that it's going to cost me to make that 301st item. So this is, don't forget, this is an approximate cost, right? But hey, look up here. How much was it? Oh, yeah, I got it. I wrote that right. Okay. Sorry for just a second. I thought I hadn't written it right, but I did. Okay. Our approximate cost was, our exact cost was $19.01, and my approximate cost is $19 even. Oh my gosh. $19 even. And it took me 1, 2, 3 lines to come up with the marginal cost instead of all of this for the actual cost. And this is why people in business classes and in the business world will often say, hey, let's just take that derivative and see what it does, right? An approximate answer that's only off by a penny or just a few cents or just a few dollars, whatever it is a pretty good approximate cost, right? If I want actual, okay, I'm going to the accountants. We're going to actually put in the actual stuff, but not a big deal. I'm sorry. I kind of jumped the gun on that one. Let me pull it back. The find the marginal cost function was b. It was the function, right? 9b. And then when the marginal cost, what is the marginal cost when x equals 300? This was, what I did here was 9c. I apologize. Oops, sorry. There we go. 9c. So this was 9b. This is 9c. So find it when x equals 300. That's exactly what we did. And then D says interpret or compare your results. That means write me a book about, not a book, but a little sentence about what you think. Is this a good approximation? Is it a bad approximation? Should we always only do the actual cost? What's going on here? Okay. So that's your opportunity to give me some stuff. Okay. The next couple work together. So 10 says, I'm sorry. Yep, 10 says f of x equals 2/3 x cubed minus 2x squared minus 6x minus 2. Find the local max or minimum, as well as any intervals of increase or decreasing slope. Use the first derivative test. Okay. So hopefully you have the first derivative test down pat. Remember, it is take the derivative, set it equal to 0, solve for your variable. Okay, to get critical values. Once you have your critical values, we need to do a sign table. And don't forget your test points. Okay, that's what we mean by use the first derivative test. Okay, so take the derivative here. F prime of x is equal to 3 times 2/3 x squared minus 4x, subtract 1, minus a 6. That goes away. Yep, we are good. So this is really, that's a 3 over 1. The 3's will reduce out, right? So this is really 2x squared minus 4x minus 6. Okay, that's my derivative, my first derivative. Set it equal to 0. Solve for your variable. Okay, I can divide a 2 out of all of this. 0 equals x squared minus 2x minus 3. Okay. And now I see this guy should factor. Minus 3 plus 1 multiplies together to give me a negative 3. But when I add it, I get a minus 3 plus 1 is negative 2. Okay, so negative 3 times 1 is negative 3, but add them, you get a negative 2. So it does indeed factor. Solve for the variable to get your critical value. X minus 3 equals 0, or x plus 1 equals 0. This guy says x equals 3. This guy says x equals negative 1. I've got my two critical values. Okay. This was a cubic, so it makes sense I'll get two critical values. Sign table and test points. Here we go. Sign table, remember that is just a number line. I've got my f of x on the bottom. I've got my f prime of x on the top. I've got x equals 3 as a critical value, and x equals negative 1 as a critical value. What was the derivative at both of those spots? It was 0, because that was what I forced it to be, right? I set it equal to 0, and then I solved. So it has to be finding me the zeros. And last but not least, I find my test points. So I'm going to use 0. I'm going to use negative 2, and I'm going to use 4. Okay. Again, you use any test points you want to. I'm going to take each of those 3 and I'm going to plug them in where? Into the first derivative, which we have right here. Okay, so 2x squared minus 4x minus 6. So f prime of 0 equals 2 times 0, 4 times 0, minus 6. That's a 0, that's a 0, that's a negative 6. Again, I don't care about the number. What I care is that it's negative right there. My derivative is negative right there. Okay, plug in the 2. I'm sorry, the negative 2. Okay, and here, negative 2 squared is a positive 4. 4 times 2 is 8. Negative 4 times negative 2 is a positive 8. 8 plus 8 is 16. Minus 6, that's a 10. Okay, and punch it in your calculator, whatever you need to do. I don't really care that it's a 10. I care that it was positive there. Okay, and then one more, we're going to plug in 4 for my test point. 4 squared minus 4 times 4 minus 6. These are positive to begin with, right? So 4 squared is 16 times 2 is 32. Negative 4 times 4 is minus 16. 32 minus 16 is 16. Minus 6 is also 10. So it's also positive. That's all I care. Okay. So what do we have going on here? We have an increasing slope, and then we have a 0 where it flattens out, or not where the slope flattens out. Slope is 0 there, right? Then when it's decreasing, and then it's increasing. So I think this is a max, and I think this is a min. So there we have that. Yay. All right. So I know what's going on here. I'm pretty happy that I know what's going on here. This is an S curve because remember it was x to the third. So it looks something like that. Okay. And the direction said find the local maxes, the local min, and any intervals of increase or decrease. Okay. So here it was increasing, right? And this is interval notation. Where was it increasing? From negative infinity all the way up here to negative 1, right? Union that with this other area where it's increasing, which is what? From 3 to positive infinity? Absolutely. Okay. And then this section in the middle, if you remember, so this is an increase, this is a decrease, and that was an increase. That's what I'm telling you. On the graph, on the original function, increase, decrease, increase. All right, so for the decrease, that's happening in between those two critical values. So between -1 and +3. Okay, so there are my intervals for increase and decrease. And it also asked me for the point, local max and local min. So we have a max at -1. I don't know what that value is. And we have a min at 3. And I don't know what that y value is. So if you wanted to find those y values, where do you go? Is it in the original function that I'm going to find a point on the graph? Or is it in the derivative that I'm going to find the point? Oh, and hopefully in my head I hear you say it's in the original function, right? So if you want to know what those y values are, you can go back way up to the original function. It was way up here. And plug in -1 and get that y value. I'm not going to do it right now. I shall trust it to you to figure that out. Okay. So that was all to say maxes, mins, increasing, decreasing. Okay. That's the slope of the tangent line, right? First derivative. But 11 takes it a step farther and says use that same function, 2/3 x to the third minus 2x squared minus 6x minus 2. Use that same function, but it says find points of inflection, intervals where the function is concave up or down. Use the second derivative test. All right. Second derivative test. So cheating just a tiny bit, go back to our previous work. We already found the first derivative, right? First derivative is 2x squared minus 4x minus 6. Okay, so we're good to go on the first derivative, but this says use the second derivative test. So hopefully everybody knows by now. I can find the second derivative by looking at the first derivative and taking the derivative of the derivative, right? So 2 times 2 is 4x to the first minus 4. This is x to the 0. That goes away. This is a 0. That goes away. So 4x minus 4 is my second derivative. Okay. But we know that's just the start. This is my second derivative. Okay. What it says is use the second derivative test. So same stuff that we did before for the first derivative test. Find the second derivative. Set it equal to 0. Okay. Solve for x. Add that 4 over. X equals 1. Find your critical value. Okay. So I've done all of that pretty quickly. It doesn't take too long. Okay. And then once I have my critical value, I'm going for the sign chart or sign table, however you want to think about it. Okay. F of x, f double prime of x, right? Because I'm doing second derivative here. Okay. And here I go. Here is my critical value. It was at the derivative, second derivative equals 0 because I forced it. And I already wrote up here what my two test points are going to be. I'm going to use 0 and 2. F double prime of 0. I'm plugging it into the second derivative. Well, my second derivative was 4x, 4 times 0, minus 4. That's a 0. That's a negative 4. All I care about here is negative, 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 negative. Okay, so if the derivative is negative, what does that tell me about my function? Is it concave up or concave down? Negative goes with down, right? Okay. And then one more, I need this test point, so I'm going to do f double prime of 2. 4 times 2 minus 4, that's an 8. Minus 4 is 4. Be a little careful here because it's not always going to change signs. Plus, plus, plus. We saw some examples where they don't always change signs, so you really do actually have to check. Okay, don't just assume that if this one was concave up, that this one was concave down. In this case, it is concave up, but it didn't have to be there. Okay. So, intervals where it is concave up. We'll start over here at the 1 and go to positive infinity, right? And intervals where it is concave down. Actually started over here at negative infinity and came up to the 1, right? Okay. So I've got those two intervals. And then the last question there said, find the point of inflection. Well, do we have a point of inflection? The answer is yes. We changed concavity, right? This guy was concave down. Again, this is an x to the third, right? This guy is concave down right here. And then right in here, it changes and suddenly it's concave up. So indeed, that is a point of inflection and it happens where x equals 1. And again, you can plug that in and figure out what your y value is. Where am I plugging that in? It's a point of inflection. That's a point on the graph. So I need to plug it into the original function. So be careful about that if you want to find that value. All right. So there's your second derivative test. And goodness, that just takes a lot of effort, right? Okay. All right. Use the graph to the right, describe the following, estimate the intersections. Okay, so I said that because it's not a really pretty graph. It's all right. Increase, well, it's increasing here and it's increasing here. So I think it's increasing from about -1 to 0. And again, starting around 1 to infinity. Those two look like the increasing areas. Decrease looks like from negative infinity to the -1 here. And then again, it looks like it's decreasing here between 0 and 1. Constant, well, that would be a flat part of the graph. There's not one. Maximums, yeah, I think there's one here and they mean local maxes, right? At 0, 1. And minimums, I think there are 2. And it looks like here at -1, 0. And here at 1, oops, 1, 0. There we go. All right, so that's just reading a graph and making sure you know what we're finding here, what you're interpreting it properly. No worries. Okay. Okay, and then here's one where I ask you to put it all together. Here's your function. Find the derivative. Use the first derivative test to find intervals of increase, decrease, constant, local maxes and mins. Find the second derivative. Use the second derivative test for intervals of concave up, concave down, any points of inflection. Use all the information to sketch your graph. Now notice that this is an x to the third. So, and it's positive, so we know basically what we think this guy's going to look like, but just so we all see it, number 13. And at this point, if you would like to pause the video and work this sucker out for yourself, I promise you there are 2 questions at the end of your exam where you have to use first derivative and second derivative tests. So hopefully you are good on that. Okay. I have taken my first derivative. That was A. B, I'm going to use the first derivative test, so I'm going to set it all equal to 0. I see that all of these are divisible by 2, so I'm going to divide that 2 out. 0 divided by 2 is just a 0. So I've got 0 equals 12x squared plus 5x minus 3. Yep, minus 3. Making sure it's a minus sign in there. Okay, and then here I say, okay, I think this guy will hopefully factors of 12. It's going to take me a minute. You might want to do AC or the box method. 3x and 4x. Let's think about this. Yeah. So I'm going to put a plus 3 here. That'll give me plus 9. And a minus 1 here. That'll give me minus 4. Plus 9 minus 4 gives me the -5. And negative times a positive gives me the -3. All right, cool. So either 3x minus 1 equals 0 or 4x plus 3 equals 0. X equals 1/3. Ooh, fractions, yay. 4x equals -3. X equals -3/4. All right. So I have 2 critical values. And they are fractions, but we can deal with that. Don't let it stress you out. Here's 0. Here's -1. Here's -3/4. Got my f of x and my f prime of x. Okay, this guy is one of my zeros. And over here on the positive side of things, I got a 1/3, also a 0. Okay. So I need to check for signs, SIGN. This is a sign chart. Using these points, I'm going to pick -1, 0, and 1. They seem pretty easy, pretty straightforward. Plug them into your derivative, right? Okay. So my derivative was f prime of, let's pick 0, let's do him first, is equal to 12x squared plus 5x minus 3. I'm sorry, that's not actually my derivative. My actual derivative was 24 x squared plus 10 x minus 6. That was my actual derivative. Remember, I divided by 2. Okay, 0, 0, I get a negative 6 for 0. So it's negative in here in the middle. Okay, that's a decrease, interval of decrease. And then I need to plug in the other numbers. So f prime of negative 1, 24 times negative 1 squared, 10 times negative 1 minus 6. Negative 1 squared is a positive 1 times 24. That's 24 minus 10 minus 6. That's minus 16. That should be an 8. That's a positive. That's all I care about. That's an increase. And last but not least, f prime of 1. 24 times 1 squared. 10 times 1 minus 6. This is 24 plus 10 is 34 minus 6. I think that's 28. Check my arithmetic on all of this. You always know I make mistakes too, so that's a positive. I don't really care about the number anyway. What I care about is that it's positive, which means that's an interval of increase also. Okay, so sure enough, we're going up, down, up. So yes, we have a max here, and yes, we have a min here. And so I'm going to give all that information right here. So increase, intervals of increase are happening from negative infinity up to negative 3/4 or 1/3 up to infinity. Intervals of decrease are in here and beside those two, right? From negative 3/4 up to positive 1/3. Absolutely. And then we've got maxes and mins. I have a max at negative 3/4 and whatever that value. And I have a min at 1/3, whatever that y value is. Plug those into the original function in order to find those actual points. Okay. So hang on. Let me see where I was. I'm sorry. This is 13. Use the first derivative to find all that stuff. That's still part B. All of that's part B. All right. C says, find the second derivative. Well, if f prime of x was 24x squared plus 10x minus 6, then f double prime of x is 48, 48x to the first, right? Plus 10, that x goes away, that's a 0. So here's my f double prime of x. Good deal. That's part C. And then part D says, here we go. Use the second derivative test to find any interval of concave up, concave down, or points of inflection. So 48x plus 10 was my second derivative. So take the second derivative, set it equal to 0, solve for x. X equals negative 10 over 48. That's a negative 5 over 24. Again, it's a fraction. It's not pretty, but it's doable. Okay. So I have a critical value at x equals negative 5/4. Here's my number line. The next step was find use your sine table, right? I only have one critical value here. It's negative 5/24. That's where it was 0 in the derivative, second derivative. I forced it to be 0. I only have one critical value, but I need 2 test points. So I'm going to check f prime of 0. I'm sorry, f double prime of 0. And that derivative was 48 times 0 plus 10. That's a positive. Oh, I'm sorry. That was on the 0. And then f double prime of -1, 48 times -1 plus a 10, -48 plus 10, -38. That's a negative. That's all I care about is the sign. Okay, so again, this is concavity because we're in second derivative test. This side over here is concave down. This side over here is concave up. Okay. It asks me for intervals where I'm concave down. Negative infinity up to -5/24. And concave up is -5/24 up to positive infinity, right? So remembering that this is concave down, this is concave up. And then it asked me for the point of inflection. Indeed, this did change concavity, right? And it changed it right there at -5/24 and some y value. Okay. So there's that. And the very last part of this problem, part E, says, I know it takes a while, right? Part E says, use all that information above to sketch your graph. Okay. Um, if I ask you to sketch your graph again, you're going to have to use all that information above. So let's see what we found. We have a maximum at -3/4 and some number. I don't know what it is, but it's way over here. I know I'm increasing until I get to that -3/4. Let's kind of look here. Where's my derivative? I'm sorry. Here's my derivative. I'm putting in a -3/4. A negative here would be a positive, and then a negative here, and then a negative. I feel like that's going to be positive. You can plug it in, but I think this point's going to be way up here. And then, and we'll use our graphing calculator here in a second. I have a minimum at, oops. Here's -1. I have a minimum at 1/3. And I'm betting that that guy is negative, but we'll see. And it's increase, decrease, increase. So I don't know how far these are bouncing up here, but it looks something like that. And somewhere in the middle of 5/24, it's actually a negative 5/24, right? So it's on this side, not that side, sorry. Somewhere around -5/24, I have a point of inflection. So it's going to look something like that. I would really have to find the exact y values on these points, all three of those points, to figure it out. But let's see what the graph says. Okay. I'm going to graph this function. 8x to the third plus 5x to the second minus 6x minus 22. Okay. So again, I don't know exactly what this is going to look like, but it better bounce something like this. We'll see. Oh, what's wrong? My window is really out there. I'm going to zoom fit and let's see if it does anything nice for me. Okay. So it is indeed looking like that. I think it's bouncing a little bit more than I'm seeing because I think that we're kind of zoomed out a little bit too far. So let's actually go and check the window. Look at those values. That's crazy. Negative 39,000 and positive 39,000. I don't think I need that much. Let's just say, and if I do, then I'll change it. But let's say -1,000 and positive 1,000. Maybe I do need that much. I don't know. And we'll count by 500s. There it is. I didn't need that much. I don't even need the thousands. Let's clean that up a little bit more. Let's try -100 and positive 100. I'd like to see the bounce a little bit more, and there it is. We can only see it whenever we're really kind of zooming in on that just that little piece right there is what's important, right? Let me try to change this scale. -3 to 3. There it is. That's even better. Okay, so we can see it. There it is. Increase, decrease, increase, concave down, concave up. There's a point of inflection somewhere in there. There's a tiny little max, a tiny little min. It is decreasing in there. It's just hard to see it because it's very much not much change. Okay. All right. So I think that that took me almost an hour and a half to work through. Um, and of course, I'm doing a lot of explaining and all of that. So the actual test isn't going to look exactly like that. But if you can do all of those things, if you can use the 4 different rules and figure out which rule for each derivative, that's a huge chunk of the test, is being able to figure out which rule you're using and do it relatively quickly, right? Don't drag your feet on it. Um, so I feel like if you can do all of that, you're pretty well set for the test. And I hope you have good luck on it. So as soon as I get them from everybody and all the testing centers, I will grade what I can. All right. Thanks. Have a good week. Good luck on your test.